Good morning, this is your Stat Sensei, Mr. Spence, and this is a warm-up on the T interval and its exam scores. So this college professor has 350 students in a lecture class. She claims that the average score on the final exam is 75 out of 100. A random sample of 20 exam scores is taken by a student and are as follows. A dot plot indicated that the exam scores were normally distributed. Created a 97% confidence interval for the test scores, and let's comment on the professor's claim. So, first thing we know is if we're doing a confidence interval, this is going to be our formula, x bar plus or minus t star s divided by the square root of n. And the reason we're using a t as opposed to a z is because we have to use the sample standard deviation. We don't know the population standard deviation. Had they given us the population standard deviation, we would have used a z, but since we have to calculate it from the sample, we're using a sample standard deviation, we have to use a t distribution. So x bar plus or minus t star s divided by the square root of n. All right, so to calculate t star, you're going to go inverse t, 1 minus 0.97 divided by 2. So let's do that. Second vars, inverse t, parenthesis 1 minus 0.97, close parenthesis, divided by 2. Degrees of freedom are the sample size minus 1, or 20 minus 1 in this case. And we end up getting 2.3456. And we always want to use the positive value here. All right. So I've input all this data into my calculator. So I went into stat edit. And I input all of that into column L1. And if I go stat calc 1 var stats, I find my sample mean is 75.8 and my sample standard deviation is 1.5423. And we already know our sample size is 20 because there are 20 data points, and our degrees of freedom are just plain old n minus 1 is our formula. So this will be an n minus 1 or 20 minus 1. Now, when we're drawing it, all confidence intervals are centered on x bar. So this is technically centered on 75.8. That's where we're centered. All right. And we're looking for a lower and an upper bound, and this area in between is 97%. Okay. So we can go ahead and say that this is a one sample t interval for means. And if you just write one sample t interval, that's going to be good enough for me. Now, as far as calculating the interval, we're going to go stat, test, and we're going to drop down to number 8, t interval. And we use data, and the data we use was in column L1. And we want to create a 97% interval, so let's make that 0.97. And we still see that 75.8. We still see our 1.542 and our sample size of 20. But we also see our intervals somewhere between 74.99 to 76.609. So here's our interval. So this is my lower bound, and this is my upper bound. Okay? Based on the interval, is the professor's claim plausible? Well, the professor claimed 75%. And yeah, it's plausible. 75% lies within the interval. So anything within the interval, nothing lower than 74.99 and nothing higher than 76.6. But it looks like, based on our sample, the professor's claim is plausible. All right. And in case you missed out on what was on the calculator, when I did a stat calc 1 var stats, there it is. Or stat calc 1 var stats. I'll run that real quickly. That's the information that was on the screen from the calculator, which is where I got my sample mean and my sample standard deviation. All right, I hope that helps. Look forward to seeing you on the next one. Thank you.